Did you know that the stars in the sky are distant suns? They are all huge spheres of hydrogen gas. Fusion takes place in the core of stars. 4 hydrogen atoms fuse into 1 helium atom, and in the process, light is generated. Light doesn't reach the surface instantly. In the sun, the journey takes tens of thousands of years. Depending on their surface temperature and spectral characteristics, astronomers have determined that there are 7 types of ordinary stars, from the hottest to the coolest: O, B, A, F, G, K, and M. Temperature is an important characteristic of stars. It is what gives them their color. It's basically the opposite of the faucet's hot and cold indicator. When the color is redder, the stars are cooler, and when the color is blue, the stars are hotter. These can also be up to 5 times hotter than our sun. The bigger the star, the more outer layers it has, and the more pressure is exerted on its core. So the hydrogen there fuses more intensely. That's why bigger stars are brighter and hotter. Paradoxically, they live shorter lives because it's like straw. They burn faster. After what you've heard here, can you say whether the stars from the beginning of the universe, which formed when the hydrogen density was high, lived short or long lives? Did you know that there are failed stars in the universe, meaning stellar objects that never ignite because they're too small? So their weak gravity doesn't manage to trigger hydrogen fusion. They're called brown dwarfs, and they're bigger than Jupiter. Brown dwarfs don't have enough mass to sustain the continuous fusion of hydrogen in their cores, a process that powers conventional stars. With masses between 13 and 80 times greater than Jupiter's, but less than about 8% of the Sun's mass, brown dwarfs don't generate significant heat or light, which leads to their gradual cooling and dimming. Over time, they emit mainly light in the infrared spectrum, making them hard to detect with optical telescopes in the visible spectrum. With infrared telescopes, however, their spectra are dominated by molecules like methane, ammonia, and water, which makes them easier to identify. Brown dwarfs tend to have rapid rotation periods, with some spinning on their axis in just a few hours. Since their discovery in the 1990s, brown dwarfs have become an active field of research in astrophysics. They help us understand exoplanets as well, since they share many features with gas giant planets, such as their atmosphere. Did you know that red dwarf stars can live for trillions of years? Red dwarfs are born a little larger than brown dwarfs. The red color reveals their low temperature. The gravity of red dwarfs is barely strong enough to ignite hydrogen fusion. They shine faintly and cannot be seen with the naked eye in the sky. Red dwarfs are the most common type of star in the galaxy, making up about 75% of all stars. They are relatively small and have a temperature between 2,500 and 3,000 degrees Celsius, with a mass that ranges from about 0.075 to 0.5 times the mass of the Sun, which places them significantly below the mass of our Sun. That's why they emit only a fraction of the energy that stars like the Sun produce. What makes them special is their longevity. Red dwarfs burn their nuclear fuel much more slowly than larger stars, with lifespans that can reach trillions of years. This extended lifespan exceeds the current age of the universe, which means that no red dwarf has yet died a natural death. Many red dwarfs have exoplanets orbiting them. Because they don't emit much ultraviolet light, the conditions on planets orbiting close to them could be suitable for supporting life. Because it doesn't emit much ultraviolet light, where 7 planets orbit a dwarf star. Red. That's why a telescope like James Webb is searching for habitable exoplanets orbiting around red dwarfs close to them, where it's warmer. Despite the challenges, such as stellar flares caused by strong magnetic fields, there is hope that on an exoplanet around a red dwarf we might discover life for the first time. Did you know the Sun is a yellow dwarf? Stars called yellow dwarfs are larger than those called red dwarfs. That's why fusion becomes more efficient, shortening their lifespan to just a few tens of billions of years. Yellow dwarf stars, like our Sun, are a class of medium-sized stars on the main sequence, characterized by their yellowish color and relatively moderate surface temperatures. They have surface temperatures ranging from about 5,000 to 6,000 degrees Celsius. Yellow dwarfs are powered by the nuclear fusion of hydrogen into helium in their cores, a process that emits a significant amount of light and heat. Although they are considered dwarfs, these stars can be quite powerful and bright. Our Sun, for example, has a mass about 300,000 times greater than that of Earth and radiates energy at a rate of billions upon billions of gigawatts. The lifespan of yellow dwarf stars is relatively moderate in cosmic terms, ranging between 8 and 10 billion years. As they age, yellow dwarfs become hotter and expand, eventually becoming red giants. This transformation marks the end of the stable phase of their life cycle. After losing their outer layers, a white dwarf may remain behind. Yellow dwarfs are important to us. Their stability and longevity make them favorable for planets. That's why space telescopes search for Earth-like planets around yellow dwarfs. What do you think? Will they manage to find one? We live in the internet age, but people elsewhere on this planet experience the internet differently. When I want to explore other countries virtually, I use a VPN to see what the world looks like from those countries. Surfshark is a VPN that gives you access to the entire Netflix movie database and cheaper subscriptions to some platforms like YouTube Premium, HBO, and so on. Surfshark hides your IP address and thus ensures your virtual privacy while browsing the internet. You can search for plane tickets and hotel rooms at lower prices, and the app has a minimalist, user-friendly design. With the Surfshark Alert service from Surfshark One, you can monitor your data, check for possible breaches, receive alerts, and benefit from real-time protection. And Surfshark Antivirus helps you keep your device virus-free, perform a quick or full scan of your device, benefit from real-time protection, and run quick scans. Or secure your privacy with Surfshark. Go to my link in the description and enter the promo code PREJURA and you'll get 4 months free. Did you see the blue star in the sky? It's called Spica, and in reality, it's a spectroscopic binary star, which means it's made up of 2 stars that orbit so close to each other that they can't be visually separated. One of them is a blue giant, a star 10 times bigger than the Sun. Its blue color proves that it's much hotter than the Sun. Hydrogen fusion is so efficient that Spica burns out in just a few tens of millions of years. Because of its brightness, we can see it with the naked eye, even though it is very far away. Red giants and blue giants represent different stages and classifications of stars in the universe. Red giants are stars at the end of their lives when they have exhausted the hydrogen in their core and begin to fuse helium into heavier elements. This final stage lasts for several billion years. As the star's core contracts and heats up, the outer layers of the star expand dramatically, cooling and turning red in the process, which is why they are called red giants. These stars can swell up to sizes that are hundreds of times larger than their original size. In contrast, blue giants are massive stars right from the beginning of their lives. They fuse fuel much faster than smaller stars like our Sun. Blue giants are hot and luminous, with surface temperatures ranging from 10,000 to 50,000 degrees Celsius, giving them a distinctive blue hue. Because of their large masses, the fusion process is more efficient, which shortens their lifespan, often ending in dramatic supernova explosions. Both types of giants have played a role in making us what we are today. While red giants contributed to the synthesis of heavy elements and their distribution in space, blue giants often ended their lives in the form of supernova explosions, seeding the universe with even heavier elements, thus contributing to the chemical diversity of the universe. The heavy atoms in you were once part of such giant stars. Did you know that UY Scuti, sometimes classified as a red hypergiant, is the largest star known to us and has a radius 1,700 times larger than the Sun's? Hypergiant stars are among the most massive and luminous stars in the universe, representing the extreme upper limit of stellar evolution. Because they are so large, the fusion process is very efficient, and that means a lot of energy. Due to their colossal energy output, hypergiants are often unstable. They lose matter through strong stellar winds, matter that can then contribute to the formation of nebulae. Hypergiants are classified into 2 main types, based on their temperature. Blue hypergiants, which are extremely hot and often more luminous, and red hypergiants, which are cooler but still incredibly bright. Examples include Eta Carinae, a well-known blue hypergiant, and VY Canis Majoris, one of the largest known red hypergiants. Hypergiant stars play a significant role in enriching their galaxies with heavy elements, which are essential for the formation of new stars and planets, and for the possibility of life appearing in the universe. They end in spectacular and violent explosions, such as supernova explosions, leaving behind a neutron star or even a black hole. Thank you for watching the video until the end, and thanks to Surfshark for sponsoring. Don't forget about my link in the description. That way you ensure your privacy with Surfshark and get 4 months free. Until next time, I'm Christian Prasura. You are all super cool, and I wish you all the best. Goodbye.